Hi guys. So in the previous video we talked about the feature selection and the different methods used for feature selection, right? Filter based feature selection methods, wrapper based, and embedded feature selection methods. So in this video I'm going to talk about few of the filter based feature selection methods. Um, a few are on the screen. Of course, there may be many more, but a few are on the screen. And out of these few, I'll show on Python as well, so that you can relate to these methods, to these statistical concepts, that how they are used in Python while doing the feature selection. So one of them is Pearson's correlation coefficient. This is usually used when we have the Gaussian distribution. Then we have Spearman's rank coefficient, which is usually used when we have ordinal distribution, ordinal data. Then we also have ANOVA, Kendall's rank coefficient, chi-squared. We'll show all these in upcoming videos, one by one. In this video, I'll take up Pearson's correlation coefficient and I'll show you how we use this in Python for feature selection. And also, if you are not sure about these statistical concepts, like what is Pearson's correlation coefficient or what is Spearman's rank coefficient, what is ANOVA, then you can refer to another playlist which where I have explained what are these concepts in statistics, and you can refer to that playlist and you'll get all these concepts in that playlist explained from basics. So that should help you if you don't know about these concepts here, the statistical concept we are using here. So now let's go to our ID in for Python. So for this uh, example, we are using. I'm continuing, the same sheet basically, but I've just changed the data here. So I'm using this data audit underscore risk, and the data looks like this somehow. And yeah, so we are here. Audit risk column is our y, the target variable, and others are our uh, the independent variables. So and the audit is our dependent variable, the target variable. Others are our features. So uh, so now we have about 25 features. If we count it from 0, that will make it to 24, because we counted from 0, so 24. So in total we have 25 features, and that's how we have selected. So I think you're already familiar with these codes. I've already explained these codes in my previous video, previous to previous video, I think. So here I have just taken few values. Yeah, here I'll just take 25. I hope you remember why I'm taking 25 here, because first we counted from 0, and we count from 0 to 24. If I have written 25 here, that means I'm counting till 24, not including 25. But since I'm counting it from 0, so 0 to 24 will be 25 columns. So 25 columns, and we already had seen that we have 25 features. So we are good with this. So and 0 to 20, if we count it from 0, then 25th column is our target uh, variable column, which technically is 26th column, but because we are counting it from 0, so it will be 25th column. So that's why we have written 25th here, 25 here. So now for Pearson's coefficient correlation, so we have to use this function select k best. So select k best we have imported from here, from sklearn dot feature selection import select k best. So from sklearn feature selection import select k best. That's what we have taken. And remember, we also had used train test split function here to use the train test split, but we have not used that here because our focus is on uh, Pearson coefficient correlation. So we are just focusing on that. That's why we have all the features in X and only and target variable in Y and all the columns. So we have not separated columns in test and train here in this code, which we had done in when we were talking about train test split. So don't be confused about that okay, why we have not separated our rows in train and test split here. We haven't done it because our focus is on Pearson correlation coefficient. So don't be confused there. When we are actually using it, in a actual example, then we'll use train test split as well, and then on test data, and then on train data, we can separately we can check our Pearson coefficient correlation. But here we are using all the data, all the rows. So I can also comment this here because I'm not using it here. I can comment this here. So we don't need train test split in this part of code because we are not using it here. So we are using all the rows here for our calculations. So now from sklearn.feature selection, import select k best. That's the function I have imported, and that's what I have used here. Select k best. Now as this parameter score underscore func score underscore function, you can say, we'll give which function I want to use here. F underscore regression gives us the Pearson coefficient correlation. That calculation it gives F underscore regression. I have imported this function as well here from sklearn.feature selection, import F underscore regression. So when we pass on F underscore regression to score underscore function, then we are actually telling the select k best function. Basically we are passing F underscore regression parameter to the score function. So we are telling select k best function that we have to do the calculation for Pearson coefficient correlation, right? When we do k is equal to 2, that means we are telling select k best function that we only want the top two numbers, top two features. While this calculation is being done, I need top two features based on Pearson coefficient correlation. So the best two will be, will come in for PCC variable. I hope I'm clear about it. So select k best is a function. Again, I'll repeat. Select k best is a function. First parameter score underscore function will pass F underscore regression, which we had imported here. And what F underscore regression does is it tells select k best function that we have to do the calculation for Pearson coefficient correlation. And when we pass k is equal to 2, I tell select k best function that I want top two features based on the calculation of Pearson coefficient correlation, for which we pass this value F underscore regression. So I run this function, get the values in for PCC. Then what I do, I take X and Y. I have the data in X and Y. Remember, I have all the data in X and Y, all the rows, right? X is all our features, Y is our target. So I again fit X and Y based on what we passed in for PCC variable. Basically, for PCC variable knows what we wanted through Pearson coefficient correlation here. So for PCC has this values, and based on those values, based on those parameters, I can say I'll fit, I'll fit and I'll transform X and Y again, and I'll get that value here. And now when I print X selection for PC, X cell for PC dot shape, I'll get the value here, right? So this value tells me that what is how many rows and how many columns we have in this variable, which we have derived from our calculation. So we can also see that, so basically we have two columns because we only wanted two top features, so it only has two columns here, right? So Now, assuming if we wanted that we want top three columns, so we could have changed it here, and we could have rerun again, and we would have got top three columns here, right? So if I again want top four columns, I'll again rerun here, and I'll get the top four columns here. So rows and columns, right? So that's how we calculate, and we can also see the data here actually. If we have this Excel for PCC, and see we have the top four columns here based on Pearson coefficient correlation, right? So yeah, that's it for Pearson coefficient correlation in Python. Usage of this in Python basically. So I'll continue, with other statistical concept, the usage of other statistical concept in Python for feature selection for different methods like filter methods. I'll finish filter methods first, and then I'll go to wrapper method and then embedded method. And yeah, so thanks for now.